Semiconductors. Oh, we're getting to the good part. Resistors, capacitors, and inductors generally treat all values and polarities of voltage and current the same, but there are other components whose response depends on the polarity and value of voltage and current.
So, just for curiosity, what happens when you have a continuously variable AC signal? Aren't all of those components changing? They are. They are. That's why reactance is important. So it says treats all values and polarities of voltage and current the same? Yep, they certainly do, until you start changing things. We'll get heavy into that later.
All right. They're usually constructed of so we covered conductors and insulators. Now we got semiconductors. Semi, what the heck's that mean? It's a conductor, but it's not quite as good, right? They don't conduct quite as well as metallic, but they are not a good insulator either, thus they are a semiconductor. Have the useful property that adding small amounts of certain impurities called doping. This is where doping's good. So if you want to make some money at the bar, bet somebody that doping isn't always bad. And then ask them to see if they have a cell phone. Yeah, well, then doping must be good because you got a cell phone. Couldn't have a cell phone if you didn't have doping. Doping changes the ability to conduct current. The impurities create N-type or P-type material, depending on the chemical properties of the impurity. When N-type and P-type material placed in contact, the resulting P-N junction conducts better in one direction than the other. Ooh, we can do something with that, can't we? We can make a transistor. We can make a transistor that looks a whole lot better than that early one. Did we get to the early one already? All right. So there's a semiconductor. It's called a diode. Diode is a semiconductor that only allows current to flow in one direction. Heavy-duty diodes able to handle large voltages and currents are called rectifiers. Diodes have two electrodes, the anode and the cathode. It's, you see up there on the little drawing. Cathode is identified with a stripe. There's the anode and the cathode.
Yep.
That is on the test. Large diodes for large voltages are called rectifiers, and it is a semiconductor that only allows current to flow in one direction. That's the test stuff. Diodes, LED. So we got the same thing up there, except now we got two little lines. Actually, they're arrows, I believe. Mm-hmm. And they're pointing up and away. That's because there's photons leaving that diode. It's called an LED or a light-emitting diode. That's the symbol for it. Pretty sure the symbol is one of the test questions. And light-emitting diode, LED. Special type of diode that gives off light when current flows through it. Most often used as a visual indicator. That's on the test. So it's replaced a lot of lamps. But it's a light-emitting diode, visual indicator. Construction material determines the color of the light emitted. I remember that when there was only one color. You probably do too, right, Dave?
Oh, yeah.
One color. How can we get some other color?
Remember before we had it.
Well, there's that too, but you know. Uses less power than an incandescent bulb. All right. Construction material uses less power than incandescent lamps. I replaced 4 incandescent bulbs in my slide-in truck camper. I had 4 lights. Each one took 1.25 amps of current. I put all of the LEDs in there. I got more light, and my total with all 4 on was 0.76 amps. Batteries last a whole lot longer in your RV with LED lights. So they use a whole lot less power. For the test, forward voltage drop is lower in some diode types than in others.
Can you explain that?
Nope.
Yes, I did. Yes, I can.
Sparky might. Okay.
I got lost when I was reading it.
That's okay. Forward voltage drop is, all things being equal, what's the voltage loss across that diode? And that depends entirely on the chemistry of that diode. So that's why they're saying what they're talking about here.
See, I couldn't, but he did. Forward DC current causes a light-emitting diode LED to emit light. Forward DC current. Didn't say bias, did it? Forward DC current. I thought the word was bias. It is bias, but a rectifier diode changes an alternating current into a varying direct current signal. Do not drop and break these. So this is what they used to, so that little baggie,
What do you mean they? Huh? What do you mean they used to? I used to.
Okay, hem. Used to use these to do what those 100 little things in that gray baggie did.
And some people still do. Oh, yeah.
And some people, we call them glow-in-the-dark radios or boat anchors because they weighed a ton.
Foot warmer?
Foot warmers. And it wasn't RF energy, it was just the heat required that was put out by all of the electricity flowing through these devices.
The TV technician used to come to our house every year for Thanksgiving dinner because the TV always went out for the cook.
All right, so inside of those, and some of this it's nice to know. So that's why you're getting taught this. Most of this, if not all of this, is not on the test. So don't stress out. If it is on the test, it'll be in yellow up there. Diode styles. So there's a tube diode, okay? It's got a glass tube. It's got an anode. That's that little metal piece that goes around it. It's got a heated cathode in the center. And it's got a heater to heat the cathode. Now we're already to a transistor. Okay. Function of the transistor is to variably control the flow of current. Much like an electronically controlled valve, it does the same thing. An analogy, just think of the faucet in your sink. Turn it on, you can vary it, you can turn it off. Transistors are components that can consist of 3 regions of semiconductor material of N-type and P-type. Patterns form structures that allow the transistor to use small voltages or currents to control larger ones. We call that gain. Okay, so it's a diode type tube. It consists of a glass tube, an anode. It's got a heated cathode. It's got a heater to heat the cathode.
And the tube is evacuated.
Yes, it is evacuated. It's a vacuum. That's why they're called vacuum tubes.
Slide.
So we have the transistor. One on the left, there's 2 doped with N-type material and 1 doped with a P-type material. We have N-type and P-type. The other one is the opposite. It's got P-type with 1 piece of N-type. The function of the transistor is to variably control the flow of current. This is the control, this piece here. This turns it on, and the current is either flowing this way or flowing this way. So with a little tiny bit of power here, we can control how much gets through there. It's like a valve. That's what a transistor is. Now, who read the book and could tell me what NPN, how we remember NPN?
Not pointing in, right?
Never.
Never pointing in.
Never points in. It's pointing out. Never points in. This one points in permanently. So NPN and PNP transistors. So much like an electronically controlled valve, an analogy is think of the faucet in your sink. So it's a valve, basically. Transistor components that consist of 3 regions of semiconductor material, the N-type and the P-type, and depending on how we layer them, they're a PNP or an NPN. It's the dopants that are in the material, the semiconductor material, that determine whether it's an N or a P-type material. Positives and negatives. The N-type, P-type patterns form structures allow the transistor to use small voltages to control the larger ones, and that's what we call gain in a transistor. We also have gain in antennas, but in a transistor, being able to increase the voltage by controlling it with a small voltage is called gain. It can amplify or switch voltage and currents. And notice that these things are yellow. So the transistor can amplify. It can provide power gain. Again, you're stepping up, that's gain. 2 common types of transistors are the bipolar junction transistor or BJT. Bipolar junction transistor. Just remember bipolar or BJT, either one. Field effect transistor, or the FET. We call them FETs. Field effect transistor. And there we go again. So we've got the base, collector, and emitter. And whether it's a, what is that? What type?
Never points
And
NPN, never points in. And that's a PNP. Points in permanently. Because those schematics, you're liable to get asked, what is that? or identify the PNP transistor. Might just say identify the transistor. That's the schematic diagram of a transistor. Okay, it's made from 3 alternating layers of N-type and P-type material. Each layer is connected to an electrode, the base, the emitter, and the collector. This is for the bipolar. So it's base, emitter, and collector. See where the emitter is the one that has the arrow attached, and the other one's the collector. There are 2 types based on the arrangement of the layers, and that's going to be a NPN or PNP. We will revisit these later. We've got a little better little drawing. Here's a field effect transistor. The picture's a little different, isn't it? So we have a G. What do you think that is? Gate, maybe?
Yeah.
And a D is the drain. And what would S be?
Source.
Source. Is what we go. And then this one's the same on the right-hand side there. But if you notice, the arrow is pointing in and the arrow is pointing out. It's constructed of a conducting path or channel of N-type or P-type, just like the other ones. Ends of the channel form 2 electrodes, and it's got a source, a drain, and the third one is the gate. The gate electrode is used to control the current flow through the channel. So it's just like the gate is the valve. N channel, it's pointing in, and the P channel, it's pointing out, but they're not NPN and PNP. We'll revisit these later as well. And then for a field effect transistor, here's how you remember what it is. You got this field. That means it's a field effect transistor, right? And you have source up at the top of the hill. You have a gate, and you have a drain. I didn't make it up, but if that helps you remember it, you only got to remember it maybe twice. It's not going to be on your extra test. They expect you to know this by then. Okay? So you might have to take it on your tech or your general, but after that, just forget this ugly picture. Okay, switches. It's in yellow. We have an electrician, so he's not allowed to answer these questions. Anybody know what SPST is?
Single pole, single throw.
All right, and single pole, double throw. So single pole and a single throw. One piece, two of them. Single pole and either one. It can send a path either direction. Okay? Simply does what it says. It opens or closes or switches a circuit determining on whether power can flow in or not. Single pole, single throw, SPST. Single circuit switched on or off. Single pole, double throw, SPDT. Oh, that one's yellow. They must ask us about it. Single pole, double throw is the one you need to remember. Single circuit switched between one of 2 other circuits. Relays. Relays are a fancy electronically controlled switch that's controlled by a magnet. So remember when I wrapped the wire around the iron or the metal rod? And so if you put power through there, it creates a magnet. That's how a relay works. You put power through it on one side, and that energizes an electromagnet, pulls the switch, turn the power off, the magnet releases, and a spring pulls it back. That's what a relay is. Transformers. We have a nice big one you can see real easy up here. 2 or more inductors are wound on a common core to maximize mutual inductance. So when they have mutual inductance, they're transforming things. Okay, inductors are called windings. So you've got 2 windings in a transformer or more. Could have all kinds of windings in them. A winding connected to the signal source is called the primary. So the power's coming in the primary. In special applications, there may be more than one primary. The yellow part is that the power is coming in, the source is the primary winding. The winding connected to a load is called a secondary. A load is going to be whatever it is that's eating the power, whether it's a radio, a light bulb, your cell phone, because all these little wall wart things, these all have transformers. It's common to have more than one secondary. So you can have more than one primary, more than one secondary. So primary is where the source power comes in, secondary is where it goes out. It doesn't matter which wire it is, because if I change which direction the power is coming in, I can change the function of the transformer, the same transformer, and then the secondary then becomes the primary and vice versa. But primary is where the power is coming from, secondary is where it's going out. And that is one of the circuit symbols on a schematic. That is an iron core. Notice that we've got rounded curves here. That implies an inductor. We got rounded curves here. Okay, transformers transfer AC power from the primary to each of the secondaries. Transformers work equally well in both directions. Which winding is the primary and which is the secondary depends on how the transformer is connected to the circuit. So you can switch the wires and reverse what it's doing. It can make 100 volts into 10, or it can make 10 into 100. The current changes based on which way you're going.
I got it. The other thing that don't change is the wattage. Same watts.
Yes,
But there is an inefficiency, so you get less out than you do in.
that is true. However, the power is the actual.
The current flowing changes only due to inefficiencies. Protective components, I'm not sure why they got that, but that's apparently a circuit breaker drawing, and that's a fuse. The idea being that this is going to be a lighter gauge or less current carrying capacity than the circuit that it's attached to. So that becomes the part that burns out. This is why if you put a big fuse in, a 30 amp or a 5 amp belongs, the fuse is bigger than the wire, and the wire burns out and starts a fire and burns your car down or your house or whatever. Fuses and circuit breakers are designed to protect other circuit components from current overloads, is the answer to the question. Fuses blow, they're a one-time protection, and circuit breakers trip and can be reset and reused, but don't use them as a switch. Mr. Electrician, tell us why.
They do use them as switches if they're rated
For it. I didn't know they made them that are rated for it. Okay. If you take the circuit breaker in your house and you use that as a switch, it's gonna break. It's not designed to be a switch. And after a certain number of trip, it's going to not work either. It's not gonna reset. Schematic symbol for a lamp. It's just an old wire and a little, I don't know, a hat on a loop.
Glass envelope with a filament inside.
That's really more what an LED looks like. Schematic symbol for a battery, as used on the test. A series of long and short together, and there's 2 longs and 2 shorts and a wire on each end. That's a battery. Schematic symbol for a variable inductor. Okay, so remember, the curves are an inductor. And this indicates that I can tap that inductor at any one of these points, so it's variable.
What do you mean by tap?
I thought that's a tapped inductor.
That is a tap.
Variable as an arrow.
That's probably the way it shows on the test because it's in yellow.
What does that little arrow mean though?
Okay, so it means it's variable.
So what it is the circuit is to here and from there out, and this is how much of this is being used. So the circuit is there.
Okay.
And so wire wrapped, there's a wire wrapped around an insulative center, and you move a little piece across it, a wiper, across that coil of wire, and it changes how much inductance there is.
On 315 in the book, the schematic, it shows that port with the diagonal.
Shows both.
It says port, so you've got both of them on there.
Okay. Well, it is variable, but it's a tapped inductor is what it's really is. Schematic symbol used for antenna is this little guy. It's just an upside down triangle with a thick line through the center where it connects. Putting it all together in a circuit diagram is called a schematic. Depending on what you're working on, schematics can be massive books, inches thick or more. Symbols on a schematic represent electrical components. So what do we got here? What kind of transistor is that? NPN, never points in. All right. And then that's a resistor. See the sharp edges. And we don't have an inductor up there. Okay. Questions? Yeah. What describes the ability to store energy in an electric field? This is where we covered that last week.
Delta.
We sure? Yep. All right. What is the unit of capacitance?
Alpha.
Alpha? He's correct. Mr. Faraday. What describes the ability to store energy in a magnetic field?
Delta.
Bravo.
Oh, I got a delta and I got a bravo.
Bravo is electric.
Bravo's electric, says the electrician. Delta, inductance. Wrap the wire around the magnetic core. The drill bit's what I was using. Wrap the wire around it. It creates a magnet, and that's through inductance. What is the unit of inductance?
Charlie.
What electrical component opposes the flow of current in a DC circuit? DC circuit opposing the flow of current? Bravo. What electrical component stores energy in an electric field? Didn't we just have this question?
Yeah.
But it was for a general. Electric field is? Capacitor. Magnetic field is oops, I better not say that, huh? Yeah, magnetic field is what? An inductor. Magnets are inductive. All right. What electrical component is typically constructed as a coil of wire? Same thing, right? Same subject matter. And that is a delta.
And this is just another example of why we teach this as a combined general and tech course.
What is the function of an SPDT switch? We just covered that. Single circuit is switched between one of two other circuits. Anybody disagree with that? Charlie is correct. What electrical component is used to protect other circuit components from current overloads? All right, it's a fuse. Which is true about forward voltage drop in a diode?
Alpha.
All right, it's lower in some diode types than in others, alpha. Okay, what electronic component allows current to flow in only one direction? And that's not exactly true, is it, Mr. Electrician? If you blow it out, it can keep trucking.
Yeah.
Or go the other way. Or not let anything through. One direction, diode. Which of these components can be used as an electronic switch? Electronic switch.
No.
There you go. Which of the following components can consist of three regions of semiconductor?
Bravo.
What type of transistor has a gate, drain, and source? Gate, drain, and source reminds us of a what?
Tree, river, and gate. I mean,
A field with those in them.
tree, river, gate.
No, not tree. The source is the top of the hill where the water's flowing.
But I remember the tree. You remember the tree.
All right, it's field effect. How is a cathode lead of a semiconductor diode often marked on the package?
Bravo.
With a stripe.
With a stripe.
Good job. What causes a light-emitting diode LED to emit light?
Alpha.
Forward DC. What does the abbreviation FET stand for? And no, there's no tree in FET. But hey, if that makes you remember what an FET is, more power to you. What do we got? Delta. What are the names for the electrodes of a diode? Charlie, anode and cathode. Those are the names of the electrodes of a lot of things. Your battery has an anode and a cathode. Which of the following can provide power gain? Power gain.
Bravo.
You said Bravo or Delta, I heard. You think it's Bravo? It is Bravo. The transistor can cause more power coming out from a different source than what's controlling it. The resistor is always going to create heat and reduce the amount of power. Because that's resistance causes heat buildup. And that's what burns up the power. And so it's lower. May not be a lot. What was that?
Resistance is speed.
No, it's not. It's E equals I times R. What is the term that describes a device's ability to amplify a signal? Alpha. What are the names of the electrodes of a bipolar junction transistor?
Bravo.
Emitter, base, and collector for a bipolar. Everybody agree or disagree?
Agree. It's not pole 1, pole 2 output, right?
Right.
Okay, emitter, base, and collector. What is the name of an electrical wiring diagram that uses standard component symbols? Charlie. Which of the following is accurately represented in electrical schematics?
Charlie.
Connections. Oh, which of the following devices or circuits changes an alternating current into a varying direct current signal?
Bravo.
about the ones that handle a lot of power rectifiers. That was last week. What is a relay? We're either stumped or we're reading them all. I hope you're reading them all.
Alpha.
Alpha is correct. Which of the following displays an electrical quantity as a numeric value?
Charlie.
Charlie is correct. What type of circuit controls the amount of voltage from a power supply?
Alpha.
I got one guess of alpha.
Alpha.
I got several alphas now. Alpha is correct. The place. What component changes 120 volts AC house current to a lower AC voltage for other uses? Bravo. Yes, I don't see wall warts up there. That's the common name, but it is called a transformer. Which of the following is commonly used as a visual indicator? An LED. What is the name of the device that combines several semiconductors and other components into one package? Semiconductors and other components, and there's a bunch of them, and they're in one package, and it's called a? Charlie, integrated circuit. What occurs in an LC circuit at resonance? What's an L and C circuit? L is what? L is an inductor, and C is a? It's just capacitor. Okay, so what occurs in an inductor capacitor circuit at resonance?
Delta.
We've got two deltas. Anybody else? Delta. And they cancel out. That's how we can make a trap for an antenna. And we get them to cancel out, and then it goes right on through because there's nothing there.